Okay, so in this next video what we're going to do is we're going to again take a look at sine and cosine and tangent values. And by the way, it just occurred to me, I did the same thing up above when we're talking sines. It's not that I'm avoiding cosecant, secant, and cotangent, but since they're just reciprocals of these guys, the ideologies are kind of the same. So if we can really figure out what sine and cosine and tangent are, right, then we pretty much have cosecant, secant, and cotangent, because they're just reciprocals, but the reasoning is the same. But I'm going to concentrate on the big three. With that idea, what we're going to be doing next is we're going to be taking a look at specific angle values. Now, note up to this time in most of our work, we have just been finding cosine and sine and tangent and secant values and etc. And we don't really know what the angle is, right? We just know what ratio occurs for the picture that I have in terminal sides and angles. So this will be the first time we actually take a look at a particular type of input, and we want to know what sine and cosine and tangent are for those. So let's go ahead, let me move this off here, and let's consider each case, all right? And we'll use the definition to figure out, not our calculators. So our first quadrantal angle is 0 degrees. So again, by definition, what I need is a ordered pair on the terminal side. So 0 degrees looks like this, right? Its initial side is along the x-axis, and its terminal side is along the x-axis. So looking for a point that's on this, there's many to choose from. Why don't we choose 1 over 0? All right, again, you could have choose 2 over 0, 3 over 0, it does not matter. All right, so we now know what x is and we know what y is. So what about r? Well, r, by definition, is x squared plus y squared, which is basically the square root of 1, so r is also equal to 1. So r is 1, x is 1, y is 0. And so now that we know those three values, we can go to our x, y, r definition. So what is sine of 0 degrees? Well, again, by definition, it's the y coordinate over the r coordinate. And so we end up with here is y is 0, r is 1, and so we end up with 0. So the sine of 0 degrees is equal to 0. So we now actually have a known input with a known ratio now. All right, so 0, if you put 0 into sine, your output is a 0. All right, this is an angle measure, and that's actually a real a number value. What about the cosine of 0? Well, by definition, it's x over r. For our picture, my x is 1, r is 1, so we get 1. So the cosine of 0 degrees is 1. Okay, if we did tangent of 0 degrees, by definition, it's y over x. Well, in this picture, right, y is 0, x is 1, and so 0 divided by 1 is 0. So the tangent of 0 is 0. Okay, and then just as a sneak peek, if we did, basically if we did the cosecant of 0 degrees, you can use the definition or just use your reciprocal. I'll use the definition. So we get r over y. So this is 1 over 0. So it's actually undefined because division by 0 is not good, right? If we did secant of 0 degrees, right, that's r over x, and we again get 1 over 1, and we get 1. So the secant of 0 is 1, and then the cotangent of 0 degrees, well, by definition, that'd be x over y. For the ordered pair I have, this is 1 over 0, which is again undefined. So we do start having, because of the fact that one of our coordinates is 0, we start having division by 0 problems. Okay, and from the review, recall, when I have a division by 0, I have asymptotes, vertical asymptotes. So you can already start to get a feel. I'm way into chapter 4, but again, you can see previous knowledge kind of giving me a preview what's happening. So at 0, cosecant and cotangent, right, are going to have some issues with regard to graphs, but we'll talk about that in chapter 4. Next quadrantal angle is 90 degrees. Again, let's draw a picture and get an ordered pair on the terminal side. So 90 degrees, there's our initial side. We're going to rotate, and there's our terminal side. So there's our 90-degree angle. Of course, what we need is a point on that terminal side. Probably the easiest available is 0, 1. So we now know what x is and we know what y is. What about r? Well, again, it's x squared plus y squared. We get the square root of 1. We get r is equal to 1. and we're off to the races. So what is the sine of 90 degrees? Well, by definition, it's y over r. And for the ordered pair that I have, right, y is 1, r is 1, so we get 1. So the sine of 90 degrees equals 1. All right, what about cosine? What's the cosine of 90 degrees? Well, again, by definition, it's x over r. In this picture, my x coordinate is 0. My r is 1, so we get 0. So the cosine of 90 degrees is 0. Okay, and then the tangent of 90 degrees, right? Well, that's y over x. For this picture, we have 1 over 0, so we are undefined. So the tangent of 90 degrees is undefined. And again, like I said up here, that means when we graph tangent, right, at an input of 90 degrees, its graph will have a vertical asymptote because of that division by 0, based off of our review. All right, and then of course, you guys, I'm going to let you guys go ahead and talk about the cosecant and the secant and the cotangent with reference to all this. You're just basically looking at reciprocals. Again, I'm going to concentrate on the big guys. 180 degrees, again, picture-wise, we're looking at an initial side along the x-axis. We're going to go through a half rotation, right, and we're somewhere along the negative x-axis. So what ordered pairs over here? Again, there's many of them, but why don't we choose -1, 0 as our representative ordered pair that we need for the value? And so finding r, we're going to take our x and square it, and our y and square it. Again, we get the square root of 1, so r is 1 yet again. And so using my definition, oops, let's do sine first. The sine of 180 degrees, right, again is y over r. In this case, y is 0, r is 1, we get 0. So the sine of 180 is 0 all the time. The cosine of 180 degrees, right, well that's x over r. From my picture, x is -1, r is 1, we get -1. So the cosine of 180 degrees is -1, right? The tangent of 180 by definition is y over x. For my picture, my y is 0, my x is -1, so we end up with 0. So the tangent of 180 is equal to 0. All right, and so there you have it, the big three, right? And of course, reciprocals for the next one. And then the last but not least, what we got is 270. Again, if we drew a picture of 270, my initial side is here. We're going to rotate until I'm 3/4 of a turn, right? And if so, there's a picture of 270 degrees. As far as an ordered pair is concerned, 0, -1 is nice available, right? I think without going through the operation again, we know that r is going to be a 1. So here's x and here's y. So the sine of 270 degrees, by definition, it's my y value over my r. My y value is -1, r is 1, we get -1. So the sine of 270 degrees equals -1. Cosine of 270, right, well that's by definition x coordinate over r. My x coordinate is 0, r is 1, we get 0. So the cosine of 270 degrees is 0. Okay, and then tangent of 270 degrees, again by definition it's y over x. My y is -1, my x is 0, we're undefined. So the tangent of 270 does not create a value, right? So we're basically, again, when we're undefined, I talked about vertical asymptotes, but domain-wise, right, we're talking things that are in or out of the domain. And then if I go a full rotation, right, to 360, right, we're basically back to the coterminality, we're back to 0 again. So the sine of 360 will be 0, the cosine of 360 will be 1, and the tangent of 360 will be 0 as well because of the coterminality, same picture. All right, so that handles our quadrantal angles and their values. Hopefully we'll be using these so much throughout our semester, they'll just become automatic. But you should start to commit these to memory. I've always found having kind of a picture in our definition help serve as a way to kind of remember what things are as you continue just to remember it. But I'm hoping, maybe 2-3 weeks in, we'll use it so often it'll just be automatic. Yeah, and then that's, practice makes perfect. Okay, so one more thing to talk about. Let me cut that video, and then we'll be wrapping up section 1.3.